This is problem number 3 on packet number 2, and we're asked to graph the function g of x, given that g of x has the following 6 properties. So I'm going to take these properties one by one, and I'm just going to draw a little bit to give me kind of an outline of what the function would do at the beginning. I'm going to do a little bit at the beginning, and then towards the end, I'm going to put all 6 conditions together. So the first one says that the limit as x approaches infinity, g of x goes to 2. Well, what that's saying is our end behavior, so way out infinity, my function is approaching 2. Now there's a piece of that puzzle though that I'm not quite sure about. Is the function greater than 2? Or is the function coming from less than 2 as it goes out? I don't know the answer to that yet, but that's why I'm doing a little outline, if you will, of what I have, and then I can determine which part is correct there. Now, the second part, the limit as x approaches 5 from the right, that means it's coming from the right-hand side of the graph, values bigger than 5, that g of x approaches 5. Okay, so at 5, I have to go to 5. So the function is approaching 5. Now, I am pretty sure, given the 2 parts that we've worked on right here, is I think that's going to continue, and it's going to tell me that the function is approaching its farthest limit as it goes to the end behavior. It's going to be coming from the positive side versus coming from the negative side. So I'm going to believe that it's this part of the curve, but I may find as I look at more information that that's not true. Okay. Now notice I put a hole here because as a limit, it's only approaching 5. It doesn't tell me that the function equals 5 there. So the third part over here, it says the limit as x approaches 5 from the left, so values less than 5, the function is going to 3. Okay, so 1, 2, 3. Again, I'm going to draw a circle because I don't know that the function equals 3 there. I know the limit is approaching 3. Okay, so that means that I have the functions going closer to 3, the y value of 3, but again, I don't know whether it's above or below yet. So that's why the outline kind of idea. Now the fourth part, the limit as x approaches 1. Oh, since there's no plus or minus sign there, that means both the left-hand side and the right-hand side have to go to -2. So at 1, my function's limit is going to 2, which, going to -2, excuse me. That tends to make me believe that I'm going to connect the graph in this direction. Okay, those 2 pieces of information together. So for the 5th part of the information, okay, g of 1 equals -3. Well, g of 1 equals -3 is down here. I don't know whether you can see this purple very well, but now this kind of brings up the idea that where the limit is going is -2, but our function value itself, where the dot or the point is at 1, -3. Now I need to go back to our limit as x approaches 1 from the, as x approaches 1, it goes to -2, which I only did the right-hand side of that. I should have done the left-hand side as well. So somewhere in there, I have the left-hand side to deal with as well. Now the last part that this gives me, the properties given in this function, are that g of x, the limit as x approaches -infinity, g of x goes to 0. So that, again, as it goes to -infinity, that's way out here, okay? And my function is going to get closer and closer to the x-axis, but it's not going to touch it. So that kind of, as x approaches positive infinity or negative infinity, that's dealing with end behavior. Okay, so we have end behavior in these two parts of the properties, and the other 4 are working with our short-term behavior. I'm just going to put a dot at the 1, -3, because I think the purple is difficult to see. Okay, so now I need to clean this up a little bit because I was showing you different sides that this could come from. So right at the beginning, I said I didn't know whether the graph was above or below 2, but given the information in this part right here, x approaches 5 from the right, that leads me, since the function's going to be continuous everywhere else it's shown, it lets me determine that it's above the y = 2 line. So, and then I'm going to erase this little part, this little blue part right here, because I was able to determine more information. Again, okay, so I think that wraps up this problem.